Hi, welcome back to the channel. So in this video, we are going to see NPTEL answers of the subject deep learning, that is assignment number 9 of the deep learning subject in NPTEL. First question, what can be the possible consequences of choosing a very small learning rate? A slow convergence, overshooting minima, or oscillation around the minima, all of the above. The correct answer is slow convergence. So this is because the model is updating its parameters very gradually, which results in longer training time. Okay, so the second one is the equation of the update vector for momentum optimizer. Which of the following is true for this gamma? So Vt is equals to gamma into Vt minus 1 plus n delta theta j of theta. So in this case, they have given four options. So in this, the correct option is gamma is momentum term indicates acceleration. So this gamma controls how much of the previous update is retained, which helps to stabilize optimization process and escape local minima. So third one, what is true about momentum optimizer? So it helps accelerating stochastic gradient descent in right direction. So like this, four options are given. So it is all the answers are correct. That is all of the above for the third question. Fourth question. Let j of theta be the cost function. Let gradient descent update rule of theta t be theta I plus 1 equals to theta I plus delta theta I. What is the correct expression for delta theta I, where alpha is the learning rate? So here the correct answer is this minus alpha d by d theta I of theta I. This is the correct, because theta I plus 1 equals to theta I minus alpha into d by d theta I of theta I. Okay, so this is the correct. Fifth one, a given cost function j of theta equal to 6 theta square minus 6 theta plus 6. What is the weight update rule for gradient descent optimization as step t plus 1? Consider alpha to be the learning rate. So four option is given. So it is a little bit small confusions will occur between a and d. Let's see. So j of theta is given. So this take the delta of j of theta, that is differentiation. So you will get 12 theta minus 6. So in this case, 12 theta minus 6 is here. So this is not the correct. Let's see. So weight updation rule for t plus 1 is theta of t plus 1 equals to theta of t minus alpha into del of j of theta. So it is theta t minus alpha. Del of j of theta is this value 12 theta minus 6. So this format is not here there here. So take this 12 as 6 into 2. So take 6 here. So it is minus 6 alpha. So minus 6 alpha where you are having here as well as here. But look at here, plus 1 is there, here it is minus 1 is there. So you should get here, if you take mm, this as 6 out, so here also 6 out means it is minus 1 you will get, that is A. Okay, so that is a correct answer. There is a confusion between A and D, so correct answer is A. Okay. Similarly, sixth one, if first few iteration of a gradient descent cause the function f of theta naught and theta 1 to increase rather than the decrease, then what could be the most likely cause for this? A, we have set the learning rate to too large, and we have set the learning rate 0, we have set the learning rate very small, and learning rate is gradually decreased by the constant value after every epoch. So the correct answer is we have set the learning rate to very small value, so that it is for the first few iterations it is going to increase rather than decrease. So seventh one, for a function f of theta naught and theta naught and theta 1 are initialized at global minimum, then what should be the value of theta naught and theta 1 after a single iteration of gradient descent? So theta naught and theta 1 will update as per the gradient descent rule. Theta naught and theta 1 will remain same, depends on the value of theta naught and theta 1, depends on learning rate. The correct answer is theta naught and theta 1 remain same. So theta naught and theta 1 initialize at global minimum gradient of function. At this point, what is the value of del j of theta is 0. So if you write the weight update rule, so this quantity is 0. So theta naught and theta 1 both are same. So the eighth question is, what can be the one of the practical problems of exploding gradient? Two large update of weight values leading to unstable network, and the remaining three. So you can read the remaining three. The first one is the correct answer. That is too large an update of weight values leading to unstable network. Ninth one, what are the steps for using a gradient descent algorithm? So here they have given these 5 steps, so you should go according to the order. So by looking at this, the correct answer is D1. What is the D? First order is initialize weights and biases of the network with random values. So this is the initialization process, first one. So only this is given, so this is the correct answer. Later pass on to the input, then calculate the error between actual and the predicted. Then after that, fifth one, calculate the gradient value, then update the weights and the biases. And 10th one, so you run gradient descent for 15 iterations with the learning rate n equals to 0.3 and compute the error after each iteration. You find the value of error decreases very slowly. Based on this, which of the following conclusion seems most plausible? So from the given answer B, that is, rather than using a current value of A, use the smaller value of n. That is, the B answer is the correct answer for the 10th one. So this is the assignment answers for the deep learning subject of NPTEL for the assignment number 9. Stay tuned to this channel for the latest updates regarding this NPTEL deep learning courses, and also the remaining few of the NPTEL courses and academics related to engineering. So here the another 3 weeks are remaining for this subject for exam. I will upload all the assignment answers so that you can check. Thank you. We'll see you in the next video. Click on the bell icon for the latest notifications. Click all notifications so that you will get the immediate notification.